Thank you for everyone for attending today's webinar. My name is Lori Shelton Penizak, and today I'll be going over our RS-8800 field spectral radiometer and its functions of providing real-time field of view measurements. In this specific application today, we will be focusing on vegetation, although the RS-8800 can be used in multiple types of applications other than vegetation. The outline of today's webinar will start out by introducing the RS-8800 and its operations, functionality, and accessories that can be used for different types of applications. We will then look at our SENSA Probe accessory that specifically goes with the RS-8800 along with its functions, including real-time field of view. For most of you who are attending this webinar, you're here because you do a lot of field work, so we will take a look at how the RS-8800 is utilized in the field and look at some example applications. I will then wrap up the webinar by giving you a demo of our built-in vegetation indices, since most of you use those. The RS-8800 field spectral radiometer is very lightweight and designed ruggedly for field measurements. If you're someone who's going out in the field all the time and you need something lightweight that can cover the full spectrum of 350 to 2500 nanometers, this is definitely for you. It goes in a backpack and runs off of lithium-ion batteries for about 4 hours worth of field work. Now, I do like to make sure when I actually go in the field to bring 2 batteries, just to make sure that I have that full 8-hour day of field work. This unit is ideal not only for vegetation research, but if you're looking at soil, mineralogy, maybe if you're doing research on snow and ice, this is a great tool for that. Now, this is a high resolution, high sensitivity system. It has a spectral resolution of 2.8 nanometers in the UV, 8 nanometers in SWIR 1, and 6 nanometers in SWIR 2. This field spectral radiometer has a built-in computer inside of the unit with an IoT operating system. This will actually allow you to operate the spectral radiometer from your iPhone, Android, or tablet. I personally really enjoy this feature because this allows you to have everything into one accessory rather than having to bring out your laptop into the field. We'll see a lot more of this feature later on in the webinar, but again, this feature here is very beneficial. Let's talk about the SENSA Probe now. This is an absolutely fantastic accessory that works specifically with the RS-8800. Used in combination, again, with your Android, iPhone, or tablet, you will get a picture of the exact sample field of view that you want to scan, the angle of that scan, the solar elevation angle, and also the GPS location, making this ideal for the field. All of your data is going to be saved in ASCII format. So that means if you're someone who wants to use your data with a third-party software, you can just upload it directly instead of having to do any kind of data conversion, which is really nice. Here is a close-up of the Darwin operating software on a smartphone that's attached to the SENSA Probe. As you can see in the top left here, this is where you'll see your real-time live target. This real-time field of view, again, is going to be so beneficial in being accurate with your target sample. This also saves a picture of your sample that you are measuring as well. Here is the spectrum of the sample that you measure. And up top here in this section is where you're going to have your scan angle, your solar angle, and also your GPS locations. So, this makes it really nice having all of this information on one device. So this will really make your field campaigns run a lot smoother. Now we are going to watch a video on using the 8800 in the field. So obviously the key benefit to this unit is, you get your hyperspectral data right on target. So we can see the SENSA Probe here used in the field, collecting data by just a click of a trigger. And you get your data very fast in about 3 seconds, controlling it by your smartphone. The real-time field of view really gives you a good accurate area of your sample that you're wanting to measure. And you get your GPS location, distance to the target, and solar elevation angle. And again, it saves the photo of your sample with every measurement. Here is the 8800 flying on a UAV. For any of you doing validation work, you can see how portable it is going in a backpack. So all you're physically holding is that accessory. Here's another popular leaf clip here for anyone doing vegetation analysis. And also if you're someone doing, snow and ice measurements, this is a really ideal unit for that. If you're doing soil analysis, our contact probe is great for that. And here, this is another example of the real-time field of view allowing you to, accurately take your reference measurement, as you can see here. So it's really nice. And if you're doing other measurements other than reflectance, like radiance and irradiance, this is really great. If you need to, put your pistol grip on a tripod, or any extra field of view lenses. So here are the other accessories that we have: field of view lenses, contact probe, leaf clip, and also the RT sphere. If you're someone doing reflectance and transmittance measurements at the same time, this RT sphere is really handy, especially in the field. As previously stated, this field spectroradiometer can be used with different types of applications. So if you're a researcher who's doing, for example, vegetation analysis and soil analysis, this unit would be perfect in the sense of your features for instant field of view, but also a full range system that allows for clay identification. We do have a variety of accessories other than the SENSA Probe that you can use. The 10 and 3 millimeter contact probes, this is going to be really nice for anyone doing soil or mineralogy analysis. The benchtop probe with a sample compactor, this is a really great lab accessory. It has a built-in light source and also that sample compactor. So you could put your soil or your loose sample in the sample tray, and the little compactor will compact it down, make it even for better analysis. The pistol grips that we offer here hold the bare fiber and allow you to take measurements with the click of a button. So say you're someone who's doing a lot of tree canopy analysis. This is a very popular accessory for you guys. The bare fiber has a 25-degree field of view. So if you're someone who's wanting to have, say, an 8-degree field of view or a 4-degree field of view, we offer the field of view lenses that you can screw on to the end of the fiber. The leaf clip here is a very good accessory for those small leaves if you're doing specifically vegetation analysis. This actually has an integrated light source and a white reference as well. The really good thing about this is because the heat sink is separated in this, you don't have to worry about your sample getting too hot or you ruining your sample either. So it's a really great accessory. And then this here, as I was talking about, if you're someone wanting to take the reflectance and transmittance measurements of a sample, our portable RT sphere is really good. It's a 4-inch. So if you're interested in using that for the lab or the field, that's a really great accessory. Let's take a look at some example applications where the 8800 is used, and some of you work on these specific applications. Here is an atmospheric measurement application. If you noted in the video, we saw the 8800 flying on a UAV. So the 8800 is actually mounted here on this UAV. Now, UAVs obviously provide really accurate information on, specifically aerosol distribution throughout that atmospheric column. This is needed to better understand the composition of specific atmospheric layers for an overall greater understanding of the environment and climate change. So, the atmosphere being affected by both emissions, natural and man-made, measuring these different levels in the atmosphere can be accomplished with the RS-8800 on the UAV. So here we have an example screenshot of a solar radiance measurement where we can see all of the different types of absorption throughout the spectrum. Another popular application is going to be monitoring plant health. You can see in the picture here, we're using that unique leaf clip that we've got. Monitoring plant health, you can do that by measuring the red edge. Some of you might be doing a lot of, research on that. For those who aren't or may be interested in it, measuring plant health in the field can be done with the RS-8800. It's ideally suited for taking vegetation measurements using this leaf clip. Many factors can affect the plant health, like if you're looking at lack of water, overwatering, under-fertilization, pest infestation, poor drainage, soil compaction, and even lack of nutrients. You can measure the individual leaves with this leaf clip and see the plant health and the stress by looking at the red edge in the 680 to 760 nanometer range of your leaf spectra. The red edge is usually centered around 720. So in healthy plants, the red edge tends to shift to the longer wavelengths to the right of the spectra. And there is also a deep absorption feature at 680 nanometers, indicating that there is more photosynthesis going on, so more light being absorbed. Now, in a stressed plant, the red edge is further to the left toward the shorter wavelengths, and there is less absorption and more reflectance in a feature at 630 nanometers. So that's another popular application. So speaking of red edge, let's take a look at the vegetation indices built into our Darwin operating software for the 8800. So here we have a leaf measurement in our Darwin software. This software allows you to do real-time measurements, but also post-processing like I'm doing here. The tools drop-down menu right here, it has a few different tools that could really be beneficial, especially the vegetation analysis in particular. The first one being the USGS. Now, this is a built-in spectral library that has vegetation reference measurements. So if you were wanting to compare your leaf spectra to a reference to kind of figure out what type of vegetation you had, that tool allows you to do that. The one right below it is the vegetation indices tool, which I actually already have pulled up right here. I'm just going to maximize this. So this is a built-in tool. Using our software, you automatically have access to this. The main one used, I would say, would be the NDVI, which is the Normalized Difference Vegetation Index. So if you actually double-click on it, it not only gives you the formula, but it also gives you the reference to that as well. So if there was one that you weren't familiar with or you wanted to kind of know a little bit more information on, you could. These indices are going to be separated out by broadband and narrowband indices. Again, a very popular one is going to be the NDVI. So for those in the webinar who are not familiar with indices in general or have no idea about NDVI, simply put, NDVI helps differentiate between, vegetation from other types of land cover and determine its overall state. So it's going to allow you to define and visualize vegetated areas, on a map that you're working on, as well as detect abnormal changes in growth processes. If you are someone who are doing, say atmospheric research, the ARVI indice, this is commonly used to eliminate the effects of atmospheric aerosols. And then, we already talked about red edge. So if you're someone who's actively doing research on that, the REPI indice, which is the red edge position, this is commonly used, for example, on heavy metal contamination in vegetation. So you would actively use this indice if you're looking at the spectral response of the plant. Now, these types of leaves that are metal-induced stress, it's very important for monitoring environmentally damaged areas, such as like metal mine polluted land. One of the most commonly used indications of heavy metal stress in vegetation is to literally look at this red edge measurement in a spectra. So that means as heavy metal negatively affects the production of chlorophyll, the red edge is going to move toward the shorter wavelengths and reflectance increases at 680 nanometers. So for example, my RAPI, I've got a 706 nanometer reading. So this specific leaf measurement that I'm looking at, if I was looking at this in a heavy metal, situation, this would indicate to me that this is not contaminated with heavy metals. This tool also allows you to choose specific wavelength ranges of interest for your broadband and customize your narrowband indices as well. So, as you can see, having this built-in indices tool is very beneficial, especially to those doing any kind of vegetation or environmental research, and it really complements your other remote sensing tools. So, if you're doing validation work, ground truthing type situation, this is a really great tool for that. So to conclude this webinar, I hope that all of you have enjoyed learning about the RS-8800 and its accessories. This instrument paired with that SENSA Probe specifically is just a great tool for any kind of field campaign, whether that be atmospheric research, vegetation analysis. Having this instrument that is portable and non-destructive is just key. These built-in vegetation indices, they're very user-friendly, and honestly, it just makes life a lot easier having everything in one place. So thank you all for attending, and have a great rest of your week.